Okay, any questions? Any other questions before we start? So let's talk about subsystems. Did anybody fill out the early module feedback? Well, in the break. So let's talk about subsystems just as a contextual question. Name? What?
You mentioned the feedback.
It's on Moodle.
Yeah,
I'm sorry, I can't hear. What?
it's not open.
It's not open? Oh. It's visible though, right? Is it visible? It's visible, but it's not open?
It's 2021.
Okay, let me see. Early module feedback. Okay. Okay, open, closed. Okay. Let me see if I can. Early module feedback. Let's see if I can get that to work. Availability. Thank you. Thank you for pointing that out until 8th of November 2022. How does that look? See. Fingers crossed. Can you see the update? Yeah? Thank you. So just as a note on context, we have the initial design phase, classes, responsibilities, collaborations. Second stage is analyzing hierarchies, what we just talked about, contracts. And now we have some new goals. Simplify the patterns of communication, making it easier to understand. That's the way we simplify the patterns of communication, is by identifying subsystems. So this is another form of abstraction, and subsystems are basically implemented by interfaces in Java, right? In Java you can create an interface, and that's how you realize a subsystem. So we have collaboration graphs and subsystem cards we're going to talk about. Collaboration graphs represent the flow of information in a system. The information in the control of flow, the flow control, change dynamically as the program is being executed, right? In order to understand the overall design, we need some sort of static picture or a static representation of the flow of information. That's what collaboration graphs are for, right? They include classes, their hierarchies, contracts, and collaborations. So this is one way to represent the collaboration graph class representation. So a collaboration graph represents classes and class hierarchies using a nested representation. So this is the hierarchies we were talking about last class, but this is what it looks like in a nested representation. So a selection tool is a kind of tool, and a creation tool is a kind of tool. Right? Two drawing styles for the same idea. This is a complicated example with multiple inheritance. We're not going to dwell on this because we're not going to really deal with multiple inheritance much. Right? Ordered collection. This is that same multiple inheritance example. Array, magnitude, and so on. Here is the nested representation. So array is a type of indexable collection. Matrix is a type of array. String is a type of array. Here, look, a border indicates that a class is expanded elsewhere. So here, array is appearing here, and it's appearing here, right? So that special border indicates that. Double line shows that the class has another parent. So like here, since it's a multiple inheritance example, there's this double line, right? And so on. So complicated. So contracts and collaborations. Contracts are the way we document collaborations, or one way of documenting collaborations. So they're given by these circles, and each circle has a number, and that number describes a contract, right? Drawing collaborates with drawing elements. That's indicated by this arrow, this edge from left to right. And then that's documented with this contract, and there's a number 1. So each contract is given a unique identifier. That's what that is, really. So this notation can be used to simplify the collaboration graphs. Using information hiding, we can decide not to display the subclasses in their collaborations and eliminate sub-hierarchies that define no new contracts, right? And we're going to talk about that in more detail, right? So what is a subsystem? It's a group of classes, and they all have a common purpose, right? They fill a higher responsibility. From the outside of the subsystem, the classes work closely together to provide some sort of functionality, a shared abstract functionality, like printing, for example. From inside the subsystem, there can be a bunch of classes, and they're all collaborating with each other in a complicated way, right? And the idea is to hide that complexity from the rest of the world, or the rest of the application. By the way, these terms can be confusing, right? Superclass versus subsystem. A superclass groups a set of classes with identical responsibilities, right? That's what we were talking about in the last lecture. A subsystem is a group of classes with different responsibilities that can work together to fulfill some common purpose or some higher level goal, right? And it's analogous to the is part of, or the composite hierarchy, right? Subsystems are not inherently different from classes, just a matter of scale. So it's like subsystems have more intelligence than a class, right? A class has a certain level of intelligence, and then a subsystem expands that and says, okay, a subsystem groups together a bunch of classes together, and it gives the subsystem more intelligence so it can carry out bigger responsibilities or more complicated responsibilities. Here's an example, right? The printing example, right? Imagine you want to design printing. A subsystem to support contracts. So this contract is to print something. So there's a collaboration from outside the subsystem to inside the subsystem. This outer rectangle represents a subsystem or a collection of classes, right? Collaboration from a class outside the subsystem to inside the subsystem is redefined to be a collaboration with the subsystem, right? So if we're collaborating with a subsystem, it's connected to this collaboration with the print server. The contract used for collaboration becomes a subsystem contract. So instead of communicating and collaborating directly with another class, we're changing the pattern of communication to collaborate with the subsystem rather than with the class, directly with the class. Can anybody think of a good advantage to doing this? If we are collaborating or communicating with a subsystem rather than a class, directly with a class inside, can anybody think of why that might be advantageous? Or why that might be good? Or why that might lead to more maintainable software? Sean's not here, it looks like, so somebody else is going to have to try to answer. Can anybody think of an advantage to that? Name?
JD.
JD?
JD.
JD.
Yeah. You can change like how it's actually implemented inside about it.
Yes, Jamie, yes. You can make changes inside the subsystem without breaking everything outside the subsystem. Yes. There's a word for that. Anybody know? There's a special word for that. Good. It would be. This is a valid job interview question. Name?
Isn't it, Peter? Isn't
Peter.
it just abstraction?
Abstraction is one way, is one word, but there's a sort of more targeted word for that property. Encapsulation is another word for that. Yeah. Good. So subsystems, this is getting near the end of the design, by the way. We're getting to the end. It's not the end, but it's getting to the end. It's like the second to last stage, essentially, of the design process. Subsystems can help simplify a design near the end of the design process. It could also be used in the beginning for, like, we could have an application like Snake and then define the subsystems first. That is possible. And then go inside the subsystems to define the classes. So that's a possibility. And there's a design pattern that sort of operates in this way. You'll see a lot, like there are some patterns that appear over and over again, right? And they're really based on subsystems. A subsystem could start out as a class, but the class, it gets too many responsibilities and it has to be subdivided. We've mentioned that a few times. That subdivision could end up being a subsystem, right? In the end, everything still has to be defined in terms of classes. Even the subsystems have to be classes in the end. Do you know how we implement subsystems in Java? How would we implement subsystems in Java? Is it Peter?
Yeah.
Peter, what?
A package or module?
That's a possibility. Interfaces is what I was thinking, have an interface class to a subsystem. But it would make sense to take all the classes, for example, and put them in a package. Yeah. Subsystems are conceptual. They don't typically exist at execution time. An interface can exist at execution time, but remember, an interface is an abstract class, right? It doesn't have actual implementation. It just defines the communication pattern, right? How the communication is going to work. Name?
Ron.
Roy? Ronald?
Yeah. I'm going to ask, so is the interface a subsystem or all the classes that implement the interface on a subsystem?
That's a good question. Is the interface the subsystem or is it the classes inside? It's both. It's both. It's that interface and the classes that support it. Yes. Subsystems don't exist at execution time. Their classes exist during execution, but they don't. Sometimes one of the classes in the subsystem is an interface class. You could define a class called like printer interface, right? That's for sure. Right? They do not directly fulfill responsibilities, their classes do. So they just take messages and pass them on. Basically, like here are the messages that we support, and if we add a new printer, we can add a new message for that printer if we want to. Subsystems can lead to more general and flexible contracts, and clients access functionality via contracts. New contracts can be added without affecting the old ones. This is a major advantage of the subsystem definitions. Right, and we're going to look at the printer subsystem, right? A simple print subsystem that prints only PDF files could be extended to include a contract that specifies a file type. And then this extension needs a new contract, but the old contracts can still be supported without recoding old ones. This is what a subsystem card looks like. This is how we would document it if we were documenting the design. We have a subsystem name, and then the classes that implement the subsystem, and then the purpose of the subsystem, right? Drawing subsystem, to display a drawing, maintain a drawing, or modify a drawing. And there's a set of collaborations in here, drawing, and control point, right? Here's the description of contracts and the classes that handle those contracts. So we may have to go through our collaborations and redefine some of the collaborations to be with subsystems instead of classes directly. Right? Revise class definitions to collaborate with subsystems rather than a class in the subsystem. Clients are now insulated from future changes to how the subsystem carries out its contracts. That's also known as encapsulation, or information hiding is another way to describe that. Documentation for a subsystem is similar to that of a class. So how we identify subsystems. Collaboration graphs help to identify subsystems. So we look for strongly coupled classes. That means classes that collaborate with each other often, right? Either very often or have lots of different collaborations. So coupling can be indicated by frequency or a bunch of different, a web of many collaborations, right? Given a set of classes that appear to be strongly coupled, do they work together for some common goal or functionality? Do they have a common purpose? And can you name the set? If the answer to these three is true, then probably you have a subsystem or a good subsystem candidate. Here's an example of a subsystem for the drawing editor. Right, the drawing subsystem of the drawing editor to maintain and display a drawing. The classes involved are drawing, control point, drawing element, and drawing element's children. And remember in the hierarchies lecture, the drawing element had a whole bunch of children, like the rectangle, text element, filled element, and so on. So what does it support? Something can display itself, right? A drawing can display itself. It maintains the elements in the drawing. You can modify attributes of a drawing. You can test the location of a drawing element, modify the geometry of a drawing element, right? And these are the different classes that handle those responsibilities. There's a drawing class, control point class. There's a drawing elements parent class. Here's how we represent that graphically, the subsystem. It's the drawing subsystem right here. And these are the different contracts or methods that it supports, right? And they're then assigned to different classes inside the subsystem, right? There's a drawing element class hierarchy. So that's a little bit confusing because now we've transformed the class hierarchies into this other notation, this nested notation. Remember, drawing element, group element is a kind of drawing element, text element is a kind of drawing element, and we had linear element as a kind of drawing element. A bit confusing there. Here's that same subsystem using UML, drawn in UML notation. This one's more intuitive, isn't it? Because there aren't these numbers there. We can actually see what those actions are, right? And that class hierarchy, what used to be nested, is now in this format, this hierarchy format, which personally I find more intuitive, personally. Any questions or comments about that so far? The rest of the lecture is mostly examples of subsystems, really. Here's another subsystem in the drawing editor. It's called the Draw Editing Subsystem. It handles user interaction for editing a drawing. So you have a drawing, you want to make changes to it, and this is the subsystem that handles that. So we have a drawing editor, a tool, and its children, right? Remember, tool had a bunch of children, like selection tool, creation tool. So 6 is, this contract is number 6. It interprets the user input. The contract 7 is activate, handle mouse input, and deactivate. Here's that same subsystem in UML, represented as UML. Again, it's more intuitive because the contracts are not just numbers anymore. And then the hierarchies follow this kind of classical hierarchical representation rather than the nested one. And then we can abstract the design of the drawing editor application up to subsystems, just subsystems. So here's a GUI subsystem, here's an editing subsystem, and here's a drawing subsystem, right? If you think about it, there are some subsystems that are pretty much common to all software, not all software, but 90% of software. Right? There's a GUI subsystem. Almost all of your software is going to have some GUI. If the user is a person, right, there's always going to be a GUI subsystem. Can anybody think of another subsystem that's always going to be there for a typical application besides the GUI? What's another thing that's always going to be there? Like another subsystem or functionality. Can anybody think of one? Now that Sean's not here. Can anybody think of another subsystem that's pretty much always going to be there? I know some of you are thinking like, oh, this could be the answer, but I'm afraid to raise my hands and say it in front of everybody. So the database, there's going to be somewhere where the data is stored in your application. That's going to be a pretty standard subsystem. Right, where do you store the data? The data could be stored on a local file, could be stored over a network, could be stored in a database, could be stored in proprietary formats. But the data storage is pretty much always going to be some subsystem in every application, just like the GUI. And then there's going to be another subsystem that's common to every application used by a person. Anybody want to guess what the other one is? There are 3 that are going to be there for every, including the snake game, by the way. There's the processing subsystem. So what do? you have user inputs coming in, you have input and output from the data subsystem, and there's something in the middle, it's the processing. What do you do with the user input and the data that you're storing and getting? You process it. Something is processing it. That's the other subsystem, right? That's the drawing editor in UML, right? GUI, editing, drawing. So subsystems simplify the interactions. They simplify the patterns of communication because this is so challenging in object-oriented software. The patterns of communication, they're complicated, they're hard to follow, right? And this is what we're working on. We're addressing this complexity. So guidelines for simplifying the collaboration patterns. We want to minimize collaborations of a class with other classes and subsystems. We want to minimize the number of classes to which a subsystem delegates. And we want to minimize the number of different contracts supported by a class or a subsystem. That's to simplify the patterns of communication. Right. So minimizing collaborations of a class. So we can make the design simpler with fewer collaborations. We can reduce the collaborations. Can we reassign responsibilities or redefine contracts to create fewer collaborations? And one approach is to centralize the communications to a subsystem, right? Create a subsystem interface class that helps to hide the implementation details of the subsystem for clients. Right? That's the encapsulation and the information hiding principle. Here's an example. This is the printing example. So here we have a file and we want to print it, right? But we should hide the details of specific printers from the user, right? We know here at the university you can send a file to print and you can print it at different printers, right? You can pick it up at different printers. So here's a printing subsystem, right? One of the contracts is print file and the other one is associated with a printer. But that's not very nice, is it? We don't really want to worry about associating a file with a printer. We don't want to think about that, actually. So actually there's a way we can improve this, right? If the dot matrix printer breaks, which happens a lot, and we just want it to go to a laser printer or an inkjet printer, we don't want to think about it. So this is a better example. We have just one contract, and then the print server handles the details about associating which printer a file is associated with. So we don't have to worry about it anymore. It simplifies the pattern of communication, and we have this console subsystem here that displays notifications to the user, like go pick up your file from this printer, for example, or your file has just been printed, things like that. So minimizing delegations by minimizing the number of classes that receive a subsystem contract delegation directly. You hide more of the subsystem and get better encapsulation of the subsystem. So again, we see that encapsulation concept. That means we can make changes to the subsystem without breaking what's happening outside the subsystem. A well-designed subsystem limits the number of classes that are delegated contracts, right? That's information hiding. Here's another example. This is a different scenario. It's not the drawing editor scenario anymore. It's a different example. inventory and warehouse and sales. It's the retail setting, right, where you're trying to manage maybe a store, and you're trying to sell things, right? So if we're managing a store, we might have a cash register, a warehouse, and then we might have this subsystem, like inventory, transaction, and accounting system, right? Every time somebody buys something, they have to pay for it. First, before they have to pay for it at the cash register, then they have to pick up the item, then we need to keep a record of that transaction, and then we have to update the accounting, right? And the item comes from the warehouse. Now this is the design, the object-oriented design of that system, and it shows all the different collaborations, right? The cash register collaborates with the inventory, the transaction log, and the accounting system, but so does the warehouse. The warehouse has to know about the inventory, right? And the transaction log has to be associated with the warehouse in this design, and same with the accounting. But we could introduce the inventory subsystem. So instead of the cash register collaborating with the inventory item and the transaction log and the accounting subsystem, we introduce a subsystem called inventory manager, and then the cash register and warehouse interact or pass messages, let's say, to just that subsystem, right? And that's what it looks like. So we have a new class called Inventory Manager, and all the messages pass through the Inventory Manager. And that Inventory Manager is essentially the inventory subsystem. And then, if we make changes to inventory, it doesn't break the cash register in the warehouse, right? Because the Inventory Manager hides the complexity of the rest of the system. Does that make sense, hopefully? Minimize the contracts of a subsystem. Here we have an abstract subsystem, right, but represented by this rectangle, and it has 6 contracts, or 6 messages that pass through to the subsystem to fulfill the subsystem responsibilities. We could try to subdivide a subsystem into internal subsystems. So now we have these 2 internal subsystems that collaborate, right, here and here. And we have an external subsystem that handles only 2 contracts or 2 messages. So it simplifies the pattern of communication inside the original subsystem to outside and vice versa, right? So these 5 messages got simplified into 2. And then a few of them got moved inside the subsystem, so they're no longer exposed. So after we've identified subsystems, we have to update our design, right? Because in our collaboration phase, we had all of these collaborations between classes. But now we've introduced new classes or subsystems, and all those collaborations have to be updated. So we have contract redefinitions, collaboration redefinitions, possibly new classes that represent the subsystems. So that can cause a kind of chain reaction, so that we really have to update all of the design. So we might need to update the hierarchy graphs, the collaboration graphs for sure. We might even have to redo the walkthroughs that we originally did to make sure that all the communication and collaborations have been updated as a result of these new subsystems. Okay, that's it for subsystems. Any Questions about subsystems? I can see that everybody is just thinking about Halloween now, just thinking about how quickly they can get ready for the Halloween parties. And no longer stop thinking about subsystems. Okay, if everybody's happy, we will stop now. Only if you're happy though. If you're unhappy, stay here and you can talk to me and maybe I can make you happy. Otherwise, you're free to go. Hello.
You said that we need to reduce delegation between subsystems. Wouldn't further dividing these into